Hi geographers, and welcome to the latest video in CVA geography. Today's lesson's on coast and it's looking at waves and weathering. So what I'd like to do is write the title and complete the do now. So if you'd like to pause the video here, I'll then go through the answers shortly. Right, lovely, let's go through the answers then. Tropical storms form over water, that's 27 degrees. Shell created 65,000 jobs in Nigeria. A natural cause of climate change is orbital change. Humans enhance the greenhouse effect by releasing CO2 into the atmosphere. Erosion involves the wearing away of the land. A negative of Shell is the 12,000 oil spills in the Niger Delta. And afforestation, so planting trees, is an example of mitigation strategies. So today we'll be focusing on the types of waves there are that affect the coastline, and then looking at weathering to see how the weather can lead to rocks breaking down where they are. So the first thing to look at is the movement of water in the sea, and there are two key words I want you to write down, so please pause the video and write the key words down. The first word is swash, and swash is the movement of water up the beach, and this always happens at an angle. This is due to the prevailing wind. And the second key word is backwash. This is the movement of water back down the beach, and this happens at 90 degrees due to gravity. So swash is the water going up the beach at an angle, and backwash is the water going down the beach in a straight line at 90 degrees due to gravity. So please pause the video and just jot down the keywords swash and backwash. If you want to have a diagram of swash coming in at an angle and backwash going down straight, feel free to do so. So the next thing is just thinking, what is a wave? So waves form as wind blows over the surface of the sea. There is a friction between the wind and the surface of the water, and this causes the water at the surface to rise and create a long narrow wave. As the wave approaches the coast, friction with the seabed slows the base of the wave down, causing it to grow in height and shorten in length. Eventually the wave's crest will collapse down onto the beach. So what I need you to jot down for me is just thinking down what actually determines the power of waves, and we've got three factors. We've got wind speed, so how strong the wind is. The stronger the wind, the stronger the wave. Duration of wind, so time wind has been blowing, so the longer the wind's been blowing, the stronger the wave. And we've got another really key word here, which is fetch, okay? And this just means the distance the wave has travelled. So again, the larger the distance the wave has travelled, the larger the fetch, means the wave will have more energy and it will be stronger. So if you could jot down for me, wave energy is determined by wind speed, duration of wind, and the fetch, which is the distance the wave travels. So I've got a little quiz for you. Obviously you can't do the hand gestures, I would suggest you writing down the answer you think is correct. Which of the following does not influence wave energy? We've got wind speed, wind duration, amount of water, and fetch. The correct answer you should have wrote is amount of water. Next question. What is the correct definition of the fetch? We've got the wind that blows over the surface of the sea, the distance the wave has travelled, the amount of energy a wave has, or the speed the wave travels. I'll give you a moment. And you should have selected the distance the wave has travelled. And then the last question, which wave will have the most energy? We've got a wave with a long fetch, a wave which is formed by short bursts of wind, a wave formed by slow wind, or a wave with a short fetch. Give you a second. And the answer you should have selected is a wave with a long fetch. So if we look at this animation, we look at the UK, what we tend to get is waves in the southwest of the UK, so down here, are often stronger than waves we get at the south of the UK and on the east coast. The reason the waves are stronger here in the southwest, to places like Cornwall, is because the waves have travelled a large distance over the Atlantic Ocean. So their fetch is very large, meaning the waves have more energy. So we get destructive waves approaching the coast. Waves with a shorter fetch have less energy, and these are often called constructive waves. So I've just mentioned they're destructive and constructive waves, and what we're going to do now is just talk through and look at the different features, so what each wave is like. So we've got a destructive wave. A destructive wave causes erosion. It removes sediment from the beach. If we look at the features in the animation, we can see a destructive wave has a very strong backwash, so it takes sediment away. It's got a weak swash. Destructive waves are tall. They can be over a meter in height, and they also have a short wave frequency. So you can get 10 to 14 waves per minute, so there's lots of waves. So key features of the destructive waves is a short wave frequency, so they happen very often. They're very tall, over a meter in height. They've got a weak swash going up the beach, and a very strong backwash which erodes sand. So the destructive waves erode, they destroy the beach. Whereas constructive waves, these do not erode the beach, they deposit sediment. So they lead to beaches getting larger. A destructive wave has a strong swash, so it goes a long way when the crest falls down, it goes a long way up the beach. It's got a weak backwash, so it doesn't take a lot of sediment away. So constructive waves have a strong swash and a weak backwash. If we look at the waves are lower, so they're smaller than destructive waves, they're under a meter in height, and also they are less frequent, so you get around 8 to 10 waves per minute. So what I'd like you to do for me is I'd like you to write 4 sentences using the diagrams and the conjunction whereas to compare wave height, frequency, swash and backwash. A sentence starter is here where you might say destructive waves have a something, whereas constructive waves have a something. I'll give you time to pause it and then complete that task for me. Right, lovely. So answers you should have got is destructive waves have a taller wave height, whereas constructive waves have a shorter. Destructive waves have a short frequency, well, a high frequency I mean, whereas constructive waves have a low frequency. Destructive waves have a weak swash, whereas constructive waves have a strong swash. Destructive waves have a strong backwash, whereas constructive waves have a weak backwash. Right, just got a little quiz for you to do now. So again, just write the answers down on your sheet of paper. So number 1, destructive waves have a large. Constructive waves have a large. Number 3, what waves are taller? Number 4, what waves happen more frequently? Number 5, what waves add sediment to the beach? And number 6, what waves remove sediment from the beach? So pause there and answer the questions and I'll go through the answers. Right, good. So number 1, you should have had destructive waves with a larger backwash. Number 2 is swash. Number 3 is destructive. Number 4 is destructive. Number 5 is constructive. And number 6 is destructive. So let's put all this into an exam question. So the exam question says, using figure 11, compare 2 features of destructive and constructive waves. You need to use the figures. So if we look at the figures here, we can see destructive waves and constructive waves. We can see sediment being added to the beach and sediment being removed from the beach. You need to make sure your sentence is comparative. So you need 2 sentences comparing these 2 types of wave. You need to use words such as whereas, however, to compare the features. You need to talk about 2 features of each wave. Please pause the video here and complete the question. Right, so let's go through the answers. So what you could have got a mark for is constructive waves are spilling, whereas destructive waves are plunging. Destructive waves crests are closer together, but constructive waves are further apart. Constructive waves have a strong swash, whereas destructive waves have a strong backwash. Destructive waves are steeper. Destructive waves are higher. Constructive waves have a lower height than destructive waves. Destructive waves have high energy, whereas constructive waves have a lower energy. Constructive waves help to build up the beach, whereas destructive waves remove material. So mark your work there for me, guys, and that is fantastic. So that brings us to an end of our video on waves today. I hope you found it useful and helpful as always. Please remember to like and subscribe to keep up to date with any of the latest CVA geography videos. Bye!